We're now studying chapter 7, which is work, power, and energy. We're going to begin with work. So we'll just read through our notes here. The words work, power, and energy. Ooh. The words work, power, and energy have everyday meanings. The technical usage may be quite different. So we're going to start looking at work, power, and energy in terms of their physics definitions. So obviously they've got a little example here. Work may be something you have refused to do for your father, but its technical definition is average force times distance. I'm guessing my father wrote this, and he was quite frustrated or something. But anyway, so we had work is equal to force times distance, and then the unit of work is joules. And from this formula, this is equivalent to a Newton meter. So we have forces in newtons and distances in meters. So 1 joule is equal to Newton meters. Alright, I just want to go over, so we've got in our formula sheet, we've got work is equal to force times distance, which is the equivalent to this equation here, so that's okay. There's another equation for work. Work is equal to the change in energy. And this is actually the way I like to think about work. So another definition of work is equal to the change in energy of a system. Okay, so what this basically means is that if something requires more energy to move it, then more work must be done in order to do that. So you can think about it, if you're at the gym and you're pumping weights, if you have a 5 kilo dumbbell, then that's going to require less work to do dumbbell curls or whatever you want to do with them. It's going to take less work to lift, or less energy to lift it, than say a 10 kilo dumbbell will. So yeah, so there is some, you can think about it intuitively as well. So we'll go through a couple of questions just to go through a bit of the maths. So how much work is done in the following situations? A person raises a 20 kilogram pack through a vertical height of 50 centimeters. So if we have, just do 20 kilograms here, and we're going to lift it up here, and that's 50 centimeters, which is equal to 0.5 meters. So we have up here work is equal to force times displacement. So let's work out what the force is equal to. So it's mass times acceleration, which is going to be equal to 20 kilograms times by 9.81. So the force of gravity, that's going to overcome the force of gravity. Okay, S is going to be equal to 0.5 meters. So then work is equal to 20 times 9.81 times by 0.5, and that is equal to 98.1 joules. Okay, so let me just get my eraser. I didn't end up writing. I just put that all into the equation. I didn't need to write that down. So okay, so we just did work time is equal to force times the distance. So here's our second example. So a person strains on a large rock for 2 hours but does not move it. Okay, so the amount of work is equal to force times displacement, or distance. Displacement equals 0, S equals 0, so that means that work is equal to 0 as well. So therefore the work, we say that work on the rock is 0 joules. Okay, so the work on the rock hasn't been moved, but that doesn't mean that the person hasn't expended energy. It just means that the work on the rock, so that's the key here. But there might have been work on the muscles of the person. They might have got tired still, and they might have produced heat and other forms of energy. So if we look at the person as a system, then there might have been work done on the person, but no work done on the rock.